Okay.
Okay, so I'm looking at your resume right now. So first, can you make a brief introduction about yourself?
Yeah, I'm Mingrui Liu from University of Wisconsin-Madison. I'm uh wait, hold on. Sorry. Yeah, I'm graduating next year in June, and I'm going for MSCS there. Before that, I was in Zhejiang University, where I got my Bachelor of Engineering. Um, what would be the next part? For the most like 5 to 6 years of my CS education, I have been participating in numerous like ICPC contests, most of which are like competitive programming.
Nice.
Yeah, that's most about me. Yeah, and I like to play basketball. I guess that's a hobby. Yeah.
Okay, yeah, ICPC is definitely a well-known competition that measures a person's algorithm ability. And so do you have any related internship or project experience so that you can be better qualified for this job?
Uh, wait, okay. I guess it depends on the actual job, but let's see. So I have one internship experience, which was when I was back at ZJU, and I'm working at the anti-spoofing group at Tencent Holdings, at Tencent basically. So we are working on an Android app that performs ultrasound movement detection, and it was uh, from the Android app to the Python implementation of the module, and then replacing it with a C++ backend service. And eventually we got a 88% accuracy against PhotoLex before I left. So I actually don't know what happened after, but yeah, that's my intern experience.
Okay. Uh, can you tell me about what you know about Google?
Uh, let's see. I guess everyone, first of all, like Google is like the biggest, at least one of the biggest names in the field, right? Uh,
Yeah.
so there's a few reasons why I particularly like Google. The first reason is I like Android against Apple, which, open source and stuff. Uh, the Well, the second thing is Google has always been like the biggest player in competitive programming, like the biggest company that's engaged in competitive programming. So basically, every ICPC player thinks Google as kind of the uh, top among all companies that sponsor this kind of contests. And the third reason, I guess, is Google is very famous for its company culture. Um, yeah, it's on the better side, if not the best, in the major uh, companies in Silicon Valley. Yeah, that's most about it.
Okay. So why do you want to become a software engineer, and where do you see your career moving?
Um, Career move. Well, there's two questions, right? The first question is why do I want to become a software engineer, which I think is
Yeah.
pretty self-explaining. I've been learning uh, coding and been liking it since I was like in grade 5. So it has always been kind of my calling to this point. I've been coding for more than 12 years, more than half of my life.
Wow. That's
So
that's
yeah,
quite a long time.
yeah, it's actually pretty horrifying if you think about it. Yeah,
Yeah.
but yeah, and I guess the I like to do things more on the technical side. Like I'm sorry, yeah, I've always been like the uh, more of a technician guy other than like a management guy. But yeah, that's just at the beginning of my level, so I don't know actually where this is gonna end up.
Okay. Do you prefer to work in small teams or large teams, and why?
Oh, I prefer to work in small teams. So I guess there's a few reasons for this. The first reason is you connect better in a small teams. That is very much like an actual phenomenon because if you see the like well, I will use the ICPC example if we can do this kind of thing. So ICPC works in 3-person, which is a very small team. However, because there's only 3-person, you can actually like micro and manage everything. And then like this maximize this 3-person group, the output of this 3-person group. If you're working a big group, like sometimes you get to do that in the, I guess, group assignments in some homeworks. Oftentimes you'll see people who put no effort and the people who put too much effort, like in one project. So I think to maximize the participation of everyone, you have to be doing in a small group.
Okay,
I guess this one, yeah.
nice. So last question, do you require visa sponsorship in the future?
Yes.
Oh,
Yeah, I
okay.
guess that's the answer.
Okay, so before moving on to the actual algorithm question, I have one short question for you. So, when, in terms of strings, sometimes it contains the parentheses. If you want to check whether the parentheses are valid or not, like, whenever there's a left parenthesis, there's a right parenthesis. How do you solve that? How do you check that?
Okay. Let me like re-explain the question so I get this right. So we have a string
Yeah.
with parentheses, which by that you mean like sometimes it can be a single, sometimes it can be a double, or do you mean there's only one?
That's right.
Okay. Okay. So single double parentheses, it's let's see. If we want to check the correctness, this is an easy stack question, right? So when you go from left to right, when you go from left to right, you put the parentheses into a stack. And then whenever you have you see the top 2 elements. If the top 2 elements are the same, they must form a valid parentheses. And which means if you put everything in a stack and then just do it one by one, eventually you will have to have an empty set because at the end, the parentheses must all be valid.
Yeah,
Yeah,
I think the
yeah.
type of data structure is correct. And I'll type the link to the problem in the chats, and maybe you can try to solve that.
Yeah, okay. Let's see.
Yeah, you can share your screen and
Okay, I will. Hold on, sorry. Yeah, I need to go back to the. Sorry, hold on. I'm not actually sure where the huh.
I can only see your resume. Do you share the screen correctly?
Oh, I'm sorry. Hold on.
Yeah, okay.
So this is the whole screen. I can share this.
Yeah, okay.
Okay. And then what? And then sorry. I probably have to do this first. Yeah, I have to do this first. Sorry. So now we can share the screen. Okay. Can you see the problem?
1 moment. Oh yeah, sure.
Yeah, okay. So we'll start with only 3 types. Left, right, star, return true if it's valid. Okay, so we'll start with the start, right? Just getting there. Oh, can I do this? So I'm sorry, just however you're fine.
Yeah.
Stack. This one has to be a stacking of string of. Wait, hold on. It's a stack of characters of. Well, I'll just call this SDI. So this is stack. We want to have putting things into the stack. Checking parentheses. So first, sorry, hold on. This is kind of a different problem from before, right? Because we
Yeah,
have
it's a little
star.
bit
Right?
different from the common, checking the valid parenthesis problem, because you have another thing called the star. The star
yeah,
can be used as either left or right.
yeah, okay. I left or right on empty string, so I have to kind of rethink this. Sorry.
Yeah.
Left and right. Any left parentheses plus a. Oh, I see how this works. Yeah, okay. So it is a kind of a different problem. So you have to do, you basically have to check whether each star is a left or right or an empty string. Am I supposed to say this, by the way, or I just start coding?
I recommend you can, first write some pseudocodes and then you can start to build coding. That will
Yeah,
help
okay.
you to form a, better solution.
Yeah, okay. So we basically want to check. We basically want to check if star is actually a left or right or empty string, but we can't do that. So the general idea is we need to maintain a number, which is the number of left parentheses versus the number of right parentheses. And how this works. So we know that if if we see a left parentheses, we just say, oh, the number of left parentheses are +1. And the same thing goes for right. Right? This is easy. The problem is when we see where this is a star. When we see the star, what do? We say that it is a left parentheses, and we count the number of total stars. Is that star? Yeah, I would just call it star.
Yeah.
We count the number of them. Okay. Now, in between the string, if you get a value of less than 0, which means you have more right parentheses, then that's never going to be possible. This is return false. This is where you have more right than left in all cases, in all possible cases. Yeah, okay. In the end, you want this to have 0, but you can be larger than that. If you're larger than that, we can change the last few stars into right parentheses or empty strings, which means at most, we can just return. At most, we can change this by 2 multiplied by the number of stars. Because you are thinking about it as a left, we can just change it to right. This makes it, does that work?
Yeah, I think you are on the right direction of solving this problem, and I still recommend solving this problem using stack if you want to. But I think this way also works, of course.
Okay. Yeah, we can also do this in stacks, which means the stack. Yeah. So if we want to do this in stack, these are the sorry. This is correct. So we get left and right parentheses and the stars. And the stars are either left parentheses or right parentheses or empty string. Let me think for a moment. Hold on. This is 100. We're in the stack. So can be treated as single right parentheses or single left parentheses or an empty string.
So I can give you a hint. So for this, you don't need to only use one stack, but instead you can use 2 stacks to solve this problem.
Oh, okay. Okay. So we can have stack 1, stack 2. If we have 2 stacks, what do we have? Well, we can technically technically we can do this, which is we say stack 1 is all star equals left, and then star 2 is all like star equals to right. And yeah, do we think it's continuous? Yeah, so because we can continuously change every star from left parentheses to empty to right parentheses, which means the let's see. So these are still the same. If we see our left parentheses, stack 1, push, say, sorry, is yeah. Stack 2, push, yeah, okay. These are the same. if C is right. This is a bit weird because you need to do oh wait, this is only gonna be, oh no. Yeah, so if stack1 the size is larger than 0 and stack1 the, I think it's back, right? Stack top, sorry. Yeah, it's gonna be top. Equals to references. Then it's a right bracket and you pop. Else you do the push. Yeah, and then we do the same thing for stack 2 because these are the same. Yeah, actually this is gonna be okay. Where we get the star is left for stack 1, star is, and the star is right for stack 2.
Yeah.
It's left for stack 1. Well, I'm sorry. This is like a lot of duplicate code. Yeah, and in the end, what do we have? Stack 1 will have a bunch of left parentheses. Stack 2 will have a bunch of right parentheses.
Yeah, that's right.
We want that to happen. So so I'm gonna say this answer is true. So this only works when stack 1 is full of left parentheses and stack right is larger than 0. If stack 1 the top is not, actually the answer doesn't, we don't need the answer. Stack 1 top is not left parentheses, then we know we should return false. Otherwise, we stack 1 not pop. And then same thing goes for stack 2, except this is gonna be right parentheses. Sorry, let me left 4, stack 1 and 4 stack 2. Stack 2, and it's not gonna be return false. And in the end, we return true. Does this work? This is true. This is, we go to the stack 1, it gets 1 left. Other way, it gets 1 right. Yeah, so this is also true. These are all true, right?
Yeah.
Left, start right, it's empty. The right, it is 2 references. Yeah, these are true. What do we do next? Like, do I run the code or?
Yeah, you can run the code before submit.
Yeah. Okay, can I do this? Okay. Let's see. One dot plus C. Are we allowed to do some debugging, like an output of something, or is that?
Yeah, okay, sure, no problem. You can add some print statements if you want.
Yeah, just because this is lead code, so yeah.
Yeah.
Oh, I see. I'm sorry. Yeah. Okay. Oh, wait. That's really weird. Okay. Not gonna question that. C stack. Top is
I highly recommend, checking two stacks occasionally in your codes and see what's the output is.
yeah, okay. Let's see. I guess it's not actually possible to I'll just do that. Sorry. Sorry. Oh, I will. Okay, it goes wrong at the first sensor. Oh, sorry. I'm sorry. This is,
Sorry?
yeah. No, nothing. Sorry. Yeah,
Oh,
this works. I'm sorry. Yeah, okay.
oh, nice. That's a great solution. And yeah, that's exactly what I mean, by solving this question using two stacks. And I have another problem for you. This time we, put the parentheses into the arrays. We want to, find a exact path to check whether this path is valid or not. So I will send the link in the chat.
Yeah, yeah. Thank you. I will start sharing my screen. And yeah, here we have it. I better put this here. Let me read the problem first.
Yeah.
Measure values in no-empty string only of left and right. It's valid if any of the following conditions is true. Okay. Okay, that's just normal parentheses rules. A valid parentheses string path is a path satisfying all constraints. Start from the upper left cell, goes to the bottom right, either moves down or right, and the parentheses is valid. Okay. Return true if there exists a valid parentheses string path group, otherwise return false. Okay. The restriction is 100. So we know that 100. Okay. Do I need to output no, I only need to output true or false. Okay. So we know that checking parentheses is just taking left as +1 and right as -1. And then just every prefix sum must be larger than or equal to 0. And then in the end, you have to get 0, right? That's a very common transformation of the parentheses problems. And for this one, when we go from 0 to some point here, we have many paths. Some of them are invalid, but for the valid ones, they could be getting different, like parentheses values when we get here. In fact, it's gonna be for safety, I'm gonna say it's gonna be n plus n. It's probably gonna be less than that, but yeah, we're gonna pretend that that's true. So sorry. The first thing we should do is just to get m and n, because that's always a good thing. Grid 0 size. Yeah, okay.
Yeah.
And then what we do next is we want to say that when we get from 0, 0 to some point on the grid, whether we can achieve a value of x. So this will be a 3-dimensional Boolean vector, which is going to be large. I'm going to call this dp because it looks like it. Am I on the right path? Can I ask that?
Yeah, I think so. Yeah.
Yeah. This is kind of, yeah, okay. This is gonna be long. Sorry. It's just C++. N plus n. False. I probably should do this. No, I shouldn't. Sorry. Yeah. Okay. There's no, yeah. So for this dynamic programming, I'm gonna call it dynamic programming, even though it's kind of like a weak one. We know this is true, right? This is because this is clearly true. No. No, sorry. Yeah, we're gonna go through the follow, right?
Yeah.
DPIJK. I'm gonna do this by n plus n because this is gonna be safe. So whether we can do this depends on the path. One special occasion is when I0 and J0, when we don't actually have a path. So we just start there. So it's only gonna be valid when this is only gonna be valid when sorry, I need a helper. Value of character C. So if C is left, we say let's create 1, otherwise return is -1. Sorry, this if value grid 0, 0 is equal to K, then dpijk is true. This is the only way this can be true for I equals 0, 0 equals 0. And we just continue. Yeah, okay. Now we either have I is not 0 or J is not 0. If I is larger than 0, you could come from I minus 1.
Yeah.
When you come from I minus 1, the only way you can be true is so the ijk equals the I minus 1 J K minus value of my value, which is grid ij. This will cause a problem because this could be -1. Does this work? Yeah, this could be -1. So I'm gonna call this 10. Sorry, this not good sounding. This got not good naming. So if 10 is larger than or equal to 0, we can say this. And same thing for J. Everything is the same except for it's J minus 1. Uh, sorry. This is so. Now, in the end, what do we have? Well, we need to check n-1, n-1, which is the last grid. And we check whether if we can do 0, whether we can have 0 in the end. And yeah, I guess that's it.
Yeah.
Can I run the, yeah, I need to run the code. Oh, sorry. What was the, sorry.
Yeah, so first you initialize 3D vector. So, do you notice any, possible error?
Line 25. Let me see the line 25. No viable overload. Huh. Let me think. Oh, the vector bool is kind of a different beast. I need to do something that's like very different, which is, I know how to do this. So I need to do this. Yeah.
Yeah, that's true.
I think it's better if we copy this. It's gonna work better. So it's still kind of like the same code. Yeah. Okay. We got a runtime error on heap better buffer overflow.
Yeah, do you want to first analyze the time complexity of your solution?
Yeah, the time complexity is n multiplied by n multiplied by n plus n, which is 2e6. Right? Yeah.
Yeah, there's definitely a way to simplify that,
Okay.
You,
Yeah. Oh, wait. Do I simplify that or do I fix this, or is that the same thing? That's
I
probably
think
the same thing.
the
Yeah.
solution is, you are on the right path, but the 3D array is too large. It takes too much time and space,
Yeah, I see the problem. Okay. So if we have, I need to do a better way than this. Let me think.
You see, m, the maximum of m is 100, and the maximum is n is also 100. So you can multiply, and if you multiply, it will goes to a very large number. And
Yeah.
do you really need that amount of space?
Oh, I see. So yeah, you can do this by, let me think. By one less. By one less, right? So you move these to, wait, hold on, let me think. And yeah, you only need this. You only need this. Sorry. This will still result in the same time complexity. However, the memory is going to be one level lower, right? Because it's 3 to 2. Yeah. Okay. I'm going to call this last, which is the same as DP. Okay. And yeah. So same thing as before. I'm going to call this. Every time we want to do something, I need to, basically for every row, we first need to transport, basically transport everything from DP to last. Which means last JK equals to DPJK and DPJK equals to false. This is to transport everything.
Mhm.
Other than that, do we really have anything else that we need to care about? Temp. I-1 is still valid. Oh no, everything about DP is kind of not valid. Yeah. I-1 DP is actually lost now. And this is just DP, and this is just DP. And the order is correct. Yeah, I think it is. So in the end, we return the last one. Yeah. I'm just gonna run the code. Let's hope for this work. Let's still run timer.
So I'll give you a hint. So if you go back to the previous solution, you notice that the third dimension of your array is m plus n. I think that's quite larger than the actual value. So it's you can definitely make it to the smaller value, which also will also.
Yeah, correct. Yes. Yeah, I see. What is the largest possible value you can get?
Yeah.
Actually, it's m plus n divided by 2.
Yeah, that's true.
Yeah.
And also you can modify the the for loop as well, the range of for loop.
Yeah, actually I need to, right?
Yeah.
I call that limit. Is that m plus n divided 2? Yeah, it is. Okay. Is it really? M plus n divided 2. How many? It's m plus n minus 1 is the length.
M plus n.
M plus n minus 1 is the length.
Yeah.
The largest value is divided. Okay. So limit works. Yeah. Okay, limit works. So limit works. Does limit work? Hold on. Sorry. I'm gonna plus 1 just in case.
Yeah, I think yeah. When it's
I'm
R,
gonna plus 1.
plus 1. Yeah.
Yeah, it's I don't. Yeah. Okay. If temp is larger than 0 and temp is less than limit. What this work? I mean, this is still. Yeah. Okay. Yeah. Okay. But this is not the best solution, right? I feel like.
I think it's very close to the best solution, but yeah, maybe it's not.
Yeah, but like it looks, okay. Yeah. Okay. Do I need to, do I need to improve on that? Like, what's the next problem?
I think it's fine if you can pass the autograder,
Yeah, okay. So what's next? Okay.
Actually, you can go back to the previous, the 3D vector if you want. That will make things much easier. Just setting the third dimension equal to the limits.
Yeah, okay. This is where this works, right? Yeah, this is where this works. So we
Yeah.
can just do the limit, right? Do the
Yeah.
limit. Okay, +1. Because that's how it's gonna work. Yeah, okay.
Nice. That's much better. I think that's a great solution. And do you have any questions about our company?
Well, I guess the more common question would be like the most important question would be what would I be doing? Right? But I guess yeah.
Yeah, I think this is the first round of the interview. We will.
Yeah.
If we think the result is satisfying, we'll send probably another interview in the next few weeks also, and hopefully if you pass the algorithm interview, we can go to the team match, and then you can choose whatever team you want to go.
Yeah, okay, I see.
Yeah.
Yes, thank you.
And that's all.
That's all.
Yeah, okay, nice. We will notify the decision in like 3 to 5 business days.
Yeah, thank you.
Okay.
Okay.